Hello, today we shall discuss some of the problem solving techniques in kinematics. Initially, before taking example, let us take a freely falling ball. When a ball is dropped from certain height, the ratio of the displacement in the successive intervals of time will be in odd number ratio as 1 is to 3 is to 5 is to 7 is to so on. That is well known. In a particular displacement, Sn equal to u plus g into L minus half. If you want the displacement in a particular second, we use this formula. Initially, the ball is dropped, so u is 0. In the first second, if you want the displacement, g into 1 minus half. This comes to g by 2. Similarly, in the second second, it's not 2 seconds. Keep in mind, in the second second, we have g into 2 minus half. That is 3g by 2. And so on. If we take the ratio of displacements in successive intervals of time, the interval need not be 1 second, but equal intervals of time. Then we have the ratio, we can see here, g by 2 is to 3g by 2, and next will be 5g by 2, and so on. So the ratio comes to 1 is to 3 is to 5 is to 7, so on. So this is a very, very important ratio, because in many problems, we can solve it very easily if you remember this ratio. Now let us take an example to use this ratio and see that we can solve it in an easier way. Just remember that when a ball falls really down, the ratio of the displacements in successive intervals of time will be 1 is to 3 is to 5 is to 7 is to so on, odd number ratio. Now I shall take an example and work out how easy it becomes. I will take an overhead tank at a distance 6.4 meters from the ground level. Let us say droplets of water are falling from the overhead tank at regular intervals of time. And let us take a condition that when the first drop hits the ground, the fifth detaches from the top. So this will be 5, 4, 3, 2, 1. If we check carefully, the distance gradually increasing between the drops, between the points indicated. At the instant when the first drop hits the ground, the fifth drop detaches from the top, and if we take a photograph, the picture will be like this. And the distance between these two is lesser, between 4 and 3, little more, and still more, and increases. And that ratio also remains as 1 part here, 3 parts here, 5 parts here, 7 parts here. So totally number of parts what we have is 16 parts we have total. Suppose a question being asked, what is the distance between third and fourth drop at the instant when first drop hits the ground? This is the first drop. Between third and fourth we have 3 parts. Let us see. Distance between third and fourth drop equal to 3 parts out of total 16 parts we have of the total height from the ground, 6.4. That is 1.2 meters. Very easily we could get the answer without any cumbersome procedures. So that ratio is very important for us. So between third and fourth drop, the distance is 1.2 meters at that particular instant. When I say at that particular instant, that is the instant at which the first drop hits the ground. Okay. Sometimes they may ask you, what is the distance of the third drop from the ground? So third drop from the ground, how many parts we have? 7 plus 5 here, 12 parts. So distance of third drop from the ground is equal to how much we have here? 12 parts out of the total 16 parts of the total height. 6.4 meters. That is 4.8 meters. So very important here. The 6.4 meters is the height of the tank from the ground. So if you want the distance of the third drop from the ground, it is 4.8 meters. If you want the distance between third and fourth drop, it is 1.2 meters. In the similar way, we can calculate distance between any two drops. And this becomes the most easiest procedure to calculate instead of any other cumbersome difficult procedures. So we shall see some more techniques in the next session. Thank you.